Swayam Prabha. Digital India. Educated India.
So, how do we predict? So, we predict based on what we know, right. If we did not know about that particular sentence, we would not have predicted anything. So, we need to know about that. Okay. So, we need to know about the domain, okay, very well. For example, if I give you the word adiabatic and then ask you to find what is the next word. Okay. If you did not understand thermodynamics or if you did not study thermodynamics, it is not possible for you to fill in those words like adiabatic expansion, compression and so on. So, you require a domain knowledge to be able to fill in the missing word. You also require the syntactic knowledge about the language that you are studying. So, you need to know how the words are strung together and what is the legal way to form the sentence is something that you have to know. So, you need the domain knowledge, you require the syntax, you require the lexical knowledge. For example, if I write this word, okay, so you will be able to very quickly figure out that there is a word boundary here. So, we understand based on the language that we speak, read or write that there are two words here. So, there has to be a space, right. So, we understand the lexical structure of the language, that is we know each and every token that is written even if it is combined in as one word. Okay. And then I spoke about this knowledge about this sentence structure. How do you really construct the sentence in English language using verb phrase and noun phrase. Okay. And then there are certain words which are very hard to find. For example, the example that I gave in terms of the adiabatic expansion, right. So, it is very hard to find even though the word is known to you, unless you know the domain it is going to be difficult for you to find out. It is not very deterministic in nature. Natural language is human created and it allows you to innovatively create sentences and form new ways of forming a sentence and so on. So, it is not like any other programming language that you are used to, correct. So, some of the sentences are very familiar to us. So, we have heard this, seen this and used them several times. So, it is easy for us to very quickly construct a sentence even if something is missing. For example, if you probably would have used this several times in your mobile phone, if you are sending a birthday wish to your friend, right, and assuming that they are typing all the words, wish you many more happy returns of the day. And I am sure you would have noticed in all your mobile phones when you start typing wish you many, and then at the bottom you will see some options for you to pick words, we do not have to really write them, right. So, the mobile operating systems now have the capability to really fill in what is going to be the next word. So, in the same way we have in our brain that we have stored lot of patterns of that, and we know that when some words are started, we know that immediately what could be the next set of words that would come in. So, we want to assimilate or copy this model, so that we are able to build sentences using the machine. So, some sentences if you look at it are more likely to happen than others. So, hence we could very quickly guess what could be it. For example, if I say something and then stop in the middle, you will be able to fill in what I am really saying. For example, natural language processing is the study of, so you can fill in some of the missing words after that, right. Since we know what the domain is and you have come to some of the classes, so you would be able to know what could be the following words in that particular sentence. I was very particular in terms of saying that we had seen this several times. I have not used any of the term that we normally use in the probability. I just want to give you the normal word combination that we use, without knowing that particular subject. Now, having said that, probability would be very useful in the case where we would like to estimate what could be the next word. Probability really uses some of the observation that we had seen, and then some additional knowledge is coming from the observation, and then there are certain things which are missing. So, using the observed values, we would be able to estimate certain values, or in this case certain words, right. So, that is why if you look at the first 3 slides, you had seen several words appearing, instead of just one. So, it tells you that some of the words occur more frequently than others, or it says that some of the words occur more frequently, or the word is more likely to happen after these 2 words. So, these are the terminologies that we would continue to use from now onwards. So, I am not going to be getting into the details of the probability theory and so on. I am going to be only covering what is essential for the language model. Okay. So, as I mentioned earlier, it gives you some mechanism to make a decision. So, in the earlier case of the first 3 slides, if you look at that, the how, or, and then the last word you had happened so many number of times. So, I can say with a probability, very high probability, saying that how are you is more likely to be formed than any other sentence that had happened at the bottom of the graph. Okay. So, that decision was taken based on the sampled data. Okay. So, we can make some informed decision when there is certain degree of uncertainty and some observed data are available, correct. So, if I use those again, so as we had seen, there are so many words that form part of this, correct. So, what we have done is we take a corpus, very large corpus, and then try to find out the trigrams where how occurs as the first word, okay. And then we can form a set wherein these words occur, okay. So, this is one of our set which will contain how as the first one, you as the last one, and then the rest are available for us with respect to some kind of counting. So, we start counting how many times those middle word occur, okay, and then based on the observed data, we make some informed decision saying that how do you could be the probable sentence that we are looking at. Okay. So, it gives you the quantitative description of the chances or likelihood associated with various outcomes. You got it. So, we can also compute the probability of a sentence. You remember earlier we had been talking only about the words and the synonyms and the context surrounding those middle word, right. So, now having acquired some more tools, we should be able to form a sentence using the machine, and then we should be able to find out what could be the probability of forming this particular sentence. Is it high, low, and so on. Okay. So, again it requires a large corpus. We require to do a lot of word counting and so on. Probability of finding the next word in a sentence, how likely to predict you as the next word. So, these are all the important factors using which we would probably utilize. Likelihood of the next word is formalized through an observation by conducting an experiment, counting the words in a document. So, we start with the tokenization model. Okay. So, we are given a document or a corpus, we start actually tokenizing and then start counting how many times a particular word occurred, what are the different types that we find or the vocabulary that we have within the document, how many words are there in the corpus or a document, how many times a given type has occurred in the given document and so on. So, we will make those counts in the following slides. Okay. So, let us first define the probability. So, probability is defined as the likelihood that an event will occur. Let us take let's take the most popular example, a flip of the coin, right. So, there is a 50% chance, or when you toss a coin, there is a 50% chance that it would be a head or a tail, correct. And then the probabilities are expressed in terms of the percentage or in the decimal form or in the fraction forms, and we will be using the decimal form in most of the cases. Okay. So, let us define the important terms of the probability with respect to what we are dealing with, or document, sentence or corpus. Okay. Let us first define what is an experiment. Experiment is, in this case, is extracting the tokens from a given document. Let us assume that you have been given a document and then you are asked to tokenize that. So, that is an experiment. The tokenization experiment gives you a token at the end of it as its output. So, you tokenize the entire document and it forms a collection, right. So, what is the outcome of the experiment? The outcome of the experiment is a token in this case. Okay. So, now we have taken a document and then tokenized this. So, if you count the number of terms, or the outcome of the tokenization gives you a word, right, and there are 52 words in this experiment or in this document. Okay. The outcome of this experiment is 52 words, and we can say that this particular set of 52 words form the sample space omega, okay. And each outcome belongs to the sample space, okay. And then each sample is assigned a probability score, and the score is in between 0 and 1. Okay. So, if you define it, a probability function or the probability distribution function distributes the probability mass of 1 to all the samples in the sample space. In this case, the value 1 is distributed across the token. Okay. There are 52 terms. So, the probability of the word whether is going to be 1 by 52. Okay. So, we need to understand the constraints. So, all the words in the sample space must satisfy the following constraints. Okay. For all x belonging to the sample space, the probability of that word would be between 0 and 1. Okay. And then the sum of all the probabilities would be equal to 1. This is a very fundamental definition, and I am sure most of you would know. I am just reiterating for the sake of the NLP. Okay. So, now let us take an example We have the bag of words count as 52. If you want to pick a word from this, any word, assuming that they are all put in a bag, and then you just want to pick one word, okay, then the probability of picking any word in this is 1 by 52, or 1, or it's equal to 0.01. Okay, so this is the fraction that we have for the word whether or any other word that you will find here. Okay. Then let us now define an event for the same sample space. Okay. There are total number of words that we have is 52, as I mentioned, and then if you look at the unique words, there are only 37. Okay. Or there are 37 types of words in this particular bag of words. That means 15 words have frequencies greater than 1. Right. That means if you look at the word the, right, so you would definitely find that particular one happening more number of times than any other word. Okay. An event, let us now define an event. So, an event is a collection of samples of the same type, right. Since there are 37 types, so we can have 37 events, correct. So, if you look at the definition of that, a probability of an event is defined as the sum of the probability of the individual word that are present in that particular type. Okay. So, that means it is going to be the sum of all the occurrences of the particular word. Okay. Let us illustrate that by an example. So, here I am taking two words. Okay. So, let us assume that we are going to have two events. One is going to contain the type pack, the other one is going to contain the type the. Okay. So, you can see that there are 6 occurrences of the word the, that means the event the has 6 occurrences. So, if you want to find the probability of that, since there are 6, it is going to be 6 into 1 by 52, that is equal to 0.115. Okay. In the same case, if you look at the word pack, there are 3 counts. That means the probability of the E pack is 0.058. Okay. Okay. Let us move on to the next definition. Okay. So, again these are all very simple for those who have understood or studied probability. I am just repeating it for those who have done it long time ago or who have not done this. So, I am just trying to explain this in a very simple fashion. If you like to go and then study in detail, you may find a lot of books related to this, and a lot of examples, worked out samples are available for you to understand this more in detail. Okay. Let us look at the next term, the random variable. Random variable is a variable whose possible values are numerical outcomes of a random phenomenon. Okay. There are 2 types, one is a continuous one, another one is a discrete one. In this case, I am going to be only considering the discrete one, because we are going to have a discrete set of random variable that you will find. Okay. To capture the type token distinction, let us assume that we have defined a random variable W. Wx maps to the sample x belonging to this sample space omega. Okay. Again using a different variable, V is the set of types and the value is represented by the variable V. Okay. So, how do you put them in the formal notation? We can say the probability of the random variable equal to capital, in that you look at the capital part of that, equal to the value v is the probability of the even that the but the random variable v takes the value v. Okay. So, given the random variable v and the value v, p v equal to v is the probability of the even that v takes the value, that is p v equal to p probability of x belonging to the sample space such that v x equal to v. Okay. So, we can represent that in a very simple notation by probability of the random variable v equal to d as probability of d equal to 0.115. Okay. So, this is useful in terms of describing and constructing various events.